All right, one more video. This one is a little bit messier. So as you can see, I have my setup here inside of a cardboard box, but all it is the same device we used earlier that generates a frequency. But instead of having a spring attached to it or a string, it's just attached to a metal plate. Now this metal plate is going to be vibrating up and down, focused at the pin in the middle there. So the thing underneath is going to be driving it up and down from that pin, and it's going to be shaking this plate. Now, the thing that's going to happen here is as this pushes up and pushes down, it's going to be creating transverse waves. But this is a metal plate, so you're not going to be able to see it very well. So as it pushes up, it creates an upward wave that goes out to the outside of the plate and reflects back in towards the middle. But because it's not the same distance to everywhere on the plate, where the interference happens is much harder to predict in a situation like this. Because as this wave goes out, it reflects and then goes this way and then reflects, and it's really hard to figure out where the constructive and destructive interference will happen. So we aren't going to be able to tell just by looking at this plate where that happens, but there's something we can do instead. So to try and see this, what we're going to do is I'm going to start shaking the plate, but I'm going to shake it. Okay, so we're starting here. We're shaking the plate. We can't really see much going on here, but what I'm going to do is I'm going to dump a little bit of sand onto the plate. And when we dump the sand on the plate, what you'll notice is that there's a few places where the sand skitters away and a few places where the sand stays very much in place. So if I put grains of sand in the middle here, they get bounced all over the place and sent flying. But these grains of sand right here are not moving at all. So that tells us that for this particular mode, for this particular vibration pattern and this frequency, this little spot right here, there's no vibration happening. This spot here, no vibration. But here, here, and here, we have lots of vibration. We're going to mix things up a bit. We're going to try some different frequencies. And you're going to see the patterns are really not nearly as predictable in this situation. So the next one we're going to do is quite a bit faster, almost triple the vibrational speed. But again, as I pour some sand onto this, what we see is that the patterns has changed completely. There's no more lines. There's a circle now. There's a node there. No vibration there. No vibration there, 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 or there. But these spots all in here are all vibrating like crazy, and any sand you put on them just bounces away. And it either falls off, so I have to clean it up later, or ends up in these little pockets here where there's no vibration. Let's take a look at a few more. The faster we go, the shorter the wavelengths get, which means the patterns get more condensed and a little bit more complicated. So you'll also notice that this makes a noise, and as I speed it up, the noise rises in pitch. You'll notice that correlation. This is essentially acting as a speaker right now. It's shaking the air. The air is making it to the camera and recording this particular pitch. So the next one I want to do, you notice it got loud there, and that loudness means that we're at one of the various resonance modes. So here we are again, and we see very specific nodes where there's no vibration, and this is kind of the same shape as the last one, but it's added an extra layer. It's shrunk the whole thing down, and so this is our next resonant frequency. Okay, we'll move on to the next one that I found earlier. Again, it gets very loud, and that tells us we're at a resonant frequency. So there, increase the intensity, and there we have our next node. So this node, totally different shape. We do have two rings in the middle, and then a whole bunch of little rings around the outside. Let's look at some more. Here's another one. We'll give this some extra sand so you can see it a little bit better. The pattern starts to be getting a little bit more complex here. We'll go find some more. there's a really loud spot. So I'll turn that down a little bit. There's a new pattern. We haven't seen this pattern before. The shapes are quite a bit different than they were previously, but it's still shaking. At this point, we're shaking up and down over 1,000 times per second. This is actually 1,370 shakes per second. And when it shakes at this speed, again, nodes, no vibration. That's destructive interference. And here we have constructive interference. It's making the plate shake and making the sand run away. I've got a few more I want to show you because they get kind of complicated as we go up, and some of the patterns are really pretty. So let's take a look at another pattern here. There it is. Another nice pattern that forms. This one's at 1,700 hertz. And we're going to keep going. Again, the noise is a little loud. There's another one right here. And again, a whole new shape. So this pattern, it's not even that related. You can see that in the middle, there's a spot where there's not much movement. Even though the shaking is originating from here, there's a very small ring right around the middle with no vibration. Lots of other shapes around the side. I think I'll stick with maybe just two more to show you. Okay, so the next one I'm going to show you, this one's a little harder for it to get into. When we get into these high ones, it's moving up and down so little that shape takes quite a bit longer to form. And there it is, just a whole bunch of circles in this nice kind of grid pattern here. And I think one more should do it. Oh, I guess there was actually, there, that's a little better. And one more shape right there. So that is the last one that I wanted to show you. This is an interesting demonstration, I think, because it shows that the way and the pattern and the shape that waves behave in 2 dimensions can be very different than what we expect when we only use the 1-dimension analog that we were using before with this spring stretching back and forth or something like that. Now, if you can imagine, if you take this and extend it into 3 dimensions so that there's something shaking this way and there's something shaking that way and the whole airspace is vibrating, you can imagine the patterns could be very, very complicated. And those of you who have taken chemistry might recognize that the shapes of your orbitals, your s orbitals, your p orbitals, your d orbitals, they're also quite complicated. And it turns out it comes from the same root. The basis of those is that you have a point you have something that's moving back and forth in a wave pattern, and there's nodes and antinodes of constructive and destructive interference that create the shapes that make those orbitals that you've seen in chemistry class. Now, again, you might have seen the ring here, and then as we get out, they get more and more complicated. The same sort of thing happens in those chemistry, in those orbitals, and so we see some very interesting patterns, and it's all because of this constructive and destructive interference in a 3-dimensional space. So hopefully this 2-dimensional space gives you, we're not going to ask you any test questions on what shape you think any of these form or anything like that, but it gives you an idea of the complexity of waves and the interference patterns that happen when you've got complicated boundaries. So that's it for this video. One more to come, and it's just going to be one little phenomenon that we'd like you to explain in the last one. Hopefully that was useful. See you for the next one.